All right, with 30, 60, 90s, these are our other special right triangles that we're learning about is 30, 60, 90s. So these occur if we take an equilateral triangle and create an altitude. We kind of talked about, again, altitudes in chapter 5. And we also talked about altitudes with equilateral triangles. If you take an equilateral triangle, create an altitude, in an equilateral triangle, it bisects the side and the vertex. So what do we know about equilateral triangles? Well, we know that all the angles are congruent to each other. And how much are all those angles? They are 60 degrees. And we also know all three sides are congruent to each other. Now, if I create an altitude, I'm dropping lines straight from x all the way down at a right angle. And as we just stated, when we do this, it bisects the side. So that means this side over here and this side are congruent. It cuts the triangle perfectly in half. So if I now have an angle up here, which is 30 degrees, because it bisects the vertex. So I have a 30, 60, 90 triangle. Now I have two 30, 60, 90 triangles. How to do 30, 60, 90. Now this is going to be true for any 30, 60, 90, but the equilateral triangle cutting it in half with an altitude is a great representation of it. So S is always going to represent the smallest side. So S is going to be this here. And 2 times S is going to equal the hypotenuse. So across from your right angle is your hypotenuse. And so what about my third side? I'm going to call that side B right now, the altitude. How are we going to write this in terms of S? So that way, if I just know one side, I can find all three sides, or the two other sides. So we're going to use Pythagorean theorem. So my smallest side is S, so S squared plus B squared is equal to C squared, which C is my hypotenuse, which is 2 times S. And I'm going to square that whole thing. So I got to square the 2 as well. So I'm going to simplify that out. I have S squared plus squared. Square becomes 4S squared. And I'm going to move things over to one side. So subtract S squared, subtract S squared. And we get B squared equals S squared. And I want to get this again without the squares. So I'm going to square root both sides. And when I square root both sides, it's going to get rid of the square. So B is going to be equal to, now that 3 doesn't disappear. It doesn't simplify with the square root. So I'm going to take the S out because that square on the S goes away. And 3. So this becomes S root 3. So now I have a different phrase that I can utilize for my triangle. So across from my 30 degrees is always be my shortest side. It's always going to be the shortest side. So it's just S by itself. Across from your 90 degrees is your longest side. And that's going to be 2 times S. And then across from your 60 is S root 3. So S root 3, 2S. Doesn't quite flow like the 45, 45, 90 does, but it is something short that you can memorize and have in your memory for quizzes and tests. So S root 3, 2S. S root 3, 2S for your 30, 60, 90 triangles. So look at some examples